welcome to all to the this version or this episode of the virtual presentations by scientists to schools that are participating in the D. Howard International Education Foundation Rural STEM Initiative in collaboration with UTSA Cleese College of Engineering and Integrated Design, and with our collaborating organizations whose names are and logos are posted on our website. Today we have as a guest presenter from one of our star collaborators, the Aerospace Corporation. And let me just introduce the people that are you see on the screen. I'll start from top to bottom and give some of them an opportunity to say a few words. We have Carlos Velez from UTSA Cleese College, myself in the center with the Bach 111 flying over the D. Howard Company behind me. And we have our host for this presentation, CETA Magnet School, thanks to the Herculean effort of one of their teachers, Tracy Thomas, who is a big hero as far as I'm concerned. We'll all say hello to this wonderful crowd of students at CETA Magnet School. Thank you, Tracy. Thanks to the administration at CETA for organizing this. We next have our guest speaker, Dr. Nahum Melamed, who you will hear from in just a few moments. Let me next introduce one of our organizers for this event, Leanne. Leanne, how do you pronounce your last name? I'm sorry. You have to unmute and pronounce it.
McGinley. McGinley.
And thank you, Leanne. And do you have a few words you'd like to share with us on behalf of Aerospace Corp?
Yes, thank you so much, Wayne. And thank you so much, Tracy, for bringing the CETA kids to us. I can see their enthusiasm and it's certainly contagious. We are happy to be here to show one of our volunteers, our subject matter experts with us. But I thought I would share with you, if you wouldn't mind, about another event that we're part of. I have a 1-minute clip of a video and I'll go ahead and start sharing that now. And it's about an event that's on May 3rd. And we're hoping that you are all invited to it. And we're hoping you'll be able to come. So let me just make sure to share the right screen here. And I'll go ahead and play this video.
4th and 5th grade teachers join classes across the country for an out-of-this-world experience on National Space Day. The U.S. space industry is offering your students a look into the science and technology that will shape their generation's future on this planet and beyond. Get your students excited about the incredible wonders and potential of space by joining us for this unique 45-minute broadcast event through YouTube. There will be thrilling Q&As between students and America's leading subject matter experts on space. The program includes curriculum-approved, engaging lessons on how rockets launch, why we grow plants in space, why the U.S. is going to Mars, and how space technology shapes our everyday lives on Earth and more. There will even be a message from astronauts directed towards your students with a way to get involved and earn their own virtual mission patch. National Space Day, launching dreams and exploring futures. See you there.
Thanks so much for letting me show that to you, and you're all invited. I'll go ahead and put the link in here where you can register, but thanks so much.
Thank you, Leanne. And now from our illustrious partners on virtual presentations, Jill Ford from UTSA Cleese College.
Thank you so much, Wayne. Hi, everyone. As Wayne mentioned, my name is Jill Ford. I serve as the Assistant Dean for Student Success and Director of the Student Success Center here at UTSA's Cleese College of Engineering and Integrated Design. And we're just always so happy to participate in these presentations. Excited to hear from the Aerospace Corporation and very happy to be in partnership with the D. Howard International Education Foundation Rural STEM Initiative. And so big hello to all the CETA Elementary School kids. Great to see you here. I'm glad to be with you.
Thank you, Jill. And now, if I can, I'll introduce our guest speaker, and then I will turn the program over to Carlos Velez, who will moderate, and we'll have about a 30-minute or so presentation from our guest speaker. Then we'll open it up to questions from the students at CETA Magnet School. So I'm told that, and I've had the honor of speaking with Dr. Melamed on a number of occasions, actually in relation most of the time to the eclipse that we recently had. But he's just fantastic. His title at the Aerospace Corporation, excuse me for reading, is Project Leader Embedded Control Systems Department. And it says on the announcement that we had about this presentation that Dr. Melamed will give an enlightening talk on near-Earth asteroids, where we'll explore their fascinating dynamics, potential impact risks, and advancements in tracking, very important, and protecting our planet. And with that, I'll turn it over to Carlos and to Dr. Melamed. So over to you, Carlos, and I'll mute myself until the end.
Yeah, absolutely. So students, one thing to note is at the end of this, we will have questions, time for questions. So as we go through this presentation, I challenge you to think of some good questions, some things that you'd like to ask the presenter. So keep that in mind. And at the end, we'll come back over to you. So we'll have you come up to this great sign that we have here and ask some things. And with that, Dr. Melamed and Leanne, go ahead and take it away.
Thank you very much. Good afternoon to everyone. And I see the first slide coming on the screen. So thank you very much for participating in this exciting talk. Today we are going to talk about one of the two kinds of space objects that you're seeing flying on the screen. One of them is a satellite, which we will use for different purposes, but the main focus will be on that space rock that seems to be orbiting the sun a little bit too close to our planet Earth. So I'm hoping that all of you are excited about space, which is the next frontier. Let's move on to the next slide. And we want to talk about asteroids and comets. Asteroids and comets are space rocks that orbit the sun just like our own planet orbits the sun. And occasionally those objects come too close to our planet, and sometimes they actually collide with our planet. So what you see on this on the screen, on the right side of the screen, is an impact crater that is in the neighboring state of Arizona to California, right? So in North Arizona, there is an impact crater. It's about a mile-long crater that was created by an asteroid that collided with our planet about 50,000 years ago. So those events are very, very far in between, but when they do collide with us, they can cause substantial damage. And so we would like to defend our planet and our communities from those type of events. Next slide, please. Let's talk about the origin of those asteroids. Next slide. So we talked about satellites. There is a special kind of satellite which is called the Hubble Space Telescope. The Hubble Space Telescope is a satellite that can poke into the depth of the cosmos. And what it found is that there are humongous clouds of dust out there. Those clouds of dust, which are basically just a large amount of small particles, tends to get attracted to one another by a special force, which is called gravity. It's the same force that keeps us stable on the surface of the Earth. Everything that you hold and let go will fall into the center of the Earth. So those particles tend to get attracted to one another by the force of gravity, the same force of gravity. And if they rotate around each other, there is this interesting phenomena that is created. And so let's move to the next slide and see what is that phenomena. So here we see a dust cloud that is rotating. That video should be playing now. Lian, you might go back one slide and see if the video will play. Back one, maybe one more back. Yeah, I think you're going the wrong direction. You're going forward. So, okay, so this doesn't, the video doesn't play, I guess, looks like. It was starting to play a moment ago. If you go backward one step and click it, it might start playing. Just go back.
Yeah. I can pull it up actually really quick. So let me just, I'm going to take
Okay.
over.
Oh, here goes.
Oh,
Here
never mind.
goes.
She got it.
Perfect. Okay, so as you see here is a dust cloud that is rotating around in center, and those particles are attracted to one another by the force of gravity, and so the object that is created is going to grow in size until the pressure is just too high for it. It's going to ignite and become a star. As an example, our own sun was created this way. When the sun was created, now you can move to the next slide. Thank you. There are leftover objects that did not become part of the sun. And those objects are the planets and the moons. And again, here it's the same kind of thing. You probably want to move backward one and play it. I'm not sure why it takes so long to play the video here, but there is a small video here. It starts to play exactly. So those leftover pieces, which we call asteroids, sometimes tend to collide with our planet. And the thought is that they bring essential materials for life, like water and organic material, into our planet, which created the beginning of life on our planet. That is a wonderful thing, but another phenomenon is that they can also cause damage. Now that life on Earth has evolved and is stable, we don't want to let those objects damage the well-being of our community. So our job is to defend our planet from additional collisions by those objects. Let's move on to the next slide, please. So now let's do a quick quiz. Usually I do that in the classroom, so everybody shouts. We can try to do it here, and we just move from the very left object and running through the other objects. Would you like to try to say the name of these objects from left to right? I'm not sure if the audience is audible, but that's okay. We can skip that slide and move straight to the next one, because the answer to this quiz is right there, right? So we have the sun on the left, followed by Mercury and Venus and our own planet Earth and Mars. But between the planets of Mars and Jupiter, there is an area that's called the asteroid belt. The asteroid belt is a region of millions of space rocks, asteroids that orbit the sun, just like we do. Most of them are non-threatening to the Earth, but occasionally some of these objects tend to get ejected out of the asteroid belt and meander around the solar system. In most cases, they will collide with Jupiter or with Saturn or with Mars or even with the sun. But on rare occasions, they could collide with the Earth. And that's what we would like to prevent. We would like to become rocket scientists or spacecraft scientists or orbit scientists that will learn how to identify those hazards and prevent them from damaging our community and our property. Let's look at an example of a large asteroid in the asteroid belt. So if you can move to the next slide, please. We see a very large asteroid. It's 50 kilometers by 20 kilometers long. It's a huge object, and it has its own personal moon. As you can see, there is a small asteroid that orbits the big one. And so they are being attracted by the force of gravity, just like our sun attracts every other object, like our moon is attracted by our planet, Earth. That little asteroid is attracted by the bigger asteroid. And that little asteroid is not extremely small. It's about 1 kilometer in size. This kind of object, if it had collided with our planet, it would have caused substantial damage. So we don't want to, we want to protect our community from those kind of events. Let's move on to the next one, please. Here is an example of the impact crater in the state of Arizona. As you can see, the size of the asteroid that created the crater is about 3 school buses long. But the size of the crater is about 85 school buses long, almost a mile wide. What causes that large difference between the size of the asteroid and the size of the crater? The answer is the huge amount of kinetic energy that is embedded with the motion of the asteroid. The asteroid moves at tremendous speed of kilometers per second, several kilometers per second. So you can maybe think about moving from San Antonio to Austin in a few seconds. That's unheard of. But that speed creates a large amount of energy that creates those much, much larger craters than the size of the asteroid. If you ever travel to North Arizona, for example, to visit the Grand Canyon is not very far from this location. And it's going to be a very interesting experience to visit the visitor center at the edge of the crater, take a tour along the edge of the crater, and learn about the force of nature that can impact our well-being. Thank you. Let's move to the next slide, please. Here's an example of a meteorite. This is a part of the asteroid that actually made it down to the ground. It's made out of iron, and amazingly, the age of this piece of object is about 4.5 billion years old. It's an amazing thing to hold that type of piece in your hand. I have a few of these with me. I cannot share them with you virtually, but when I go to local classrooms, I bring those with me, and the kids are very excited to hold pieces of asteroids in their hand that could be 4.5 billion years old. It's an amazing thing to do. Obviously, this one is a very small one. The object that created the meteor crater that we saw a moment ago was about 50 meters across, about 150 feet across. So it's a much bigger object, but still these are considered relatively small objects because some of those asteroids could be in kilometers. Let's move on to the next slide. If you ever visit in Los Angeles, you might try to visit the University of Los Angeles, UCLA, University of California, Los Angeles. They have a very nice meteorite gallery where you can stop by and talk to the scientists that research those objects and also touch much bigger meteorites that came from space. Additionally, if you ever visit the Smithsonian Natural History Museum in Washington, D.C., they have even a bigger gallery with much, much bigger space rocks and an amazing exhibition of those meteorites. So either of those will be a wonderful experience for a field trip as part of your travel. Let's move on to the next one, please. So about 11 years ago, there was an event that was caught on dash cams. Those are the cameras that are installed in automobiles. That's going to be a video, and it might be the same kind of issue. We might have to wiggle. Here goes. So that person was driving to work in the morning, and suddenly there was an explosion in the sky by an asteroid that entered the atmosphere, created a brightness that was much brighter than the sun for a few seconds. So this is a real event. You can stop it now. This is a real event that happened 11 years ago over the city of Chelyabinsk in Russia. The reason why the asteroid was not discovered is because it arrived to the Earth from the direction of the sun. So our telescopes were blinded. They just couldn't find it in the middle of the day. They cannot see objects that arrive from the direction of the sun in the middle of the day. So we need some brilliant minds that would say, hey, I would like to discover asteroids when I grow up. Maybe I will be an astronomer or an aerospace engineer that can devise techniques to find those asteroids, even if they appear into the Earth in the middle of the day. I think that would be very, very useful if some of you will decide to become aerospace engineers. Let's move on to the next slide. Let's see how we discover those asteroids. So let's move on to the next slide. We'll see an example. And here you can see a dot of light that moves across the fixed stars. The way we discover asteroid is only in the middle of the night. So we take an optical telescope and aim it at the sky and hope for clear skies and look for dots of light that move across the galaxies and the stars that are already known to us. If we see a new dot like the one that is circled on the screen that moves across, we immediately would like to find out if that object is on the catalog. If it is on the catalog, then we know about it. If it is new, we want to study it. We want to learn whether this object might come to impact with our planet one day and might have to do something about it. And that is something that many in the US and also in the international community are doing. So NASA is engaged with that. Some of the universities have departments that deal with finding and characterizing those asteroids. And maybe some of you will want to find those asteroids and characterize their orbits. You know, there are experts that learn how to calculate their orbits and tell us whether they're going to come back to impact with our planet. Maybe some of you will be orbit experts. And maybe some of you will learn what those asteroids are made out of. Are they going to bring us some water and minerals, or are they going to cause damage? It's a very exciting field, I think. So now let's move on to the next slide. And I'm not sure how dark is the room, the auditorium in your area there. You might try to turn off the lights for just a minute or two, because we're going to practice finding an asteroid. So what you see on the screen here is a picture of the night sky before a new asteroid was discovered. So take a look at this picture. If you are in the dark, it's much, much better. And in a moment, we are going to transition to another picture of the sky, which represents a new dot of light there. So let's move on to the next slide. And now a new dot has appeared. I'm not sure if you can identify it, and I'm not sure if you can, Leanne, move back to the previous one kind of couple of times. Yeah, so the previous one is before the dot appeared. And try to look at the night of sky. You see that this is really, really a tough problem to find a new dot of light that just kind of randomly appears in the sky, in the night sky. So scientists employ computer programs that look at those pictures and automatically try to find those new dots of lights in the sky instead of letting people work very hard. So maybe some of you will be computer scientists that will devise the software and the algorithms that will help us identify new asteroids and track their orbits. So let me help you with this. Let's move on to the next slide. And you can see that the arrow points to a very little tiny new dot of light that appeared there. I'm assuming that most of you did not find it because it's very, very tough to find. I did not find it the first time I looked at this picture. I had to have this help that tell me, oh, this is the new dot of light that appeared in the middle of the night sky. So now we take another shot of the night sky a day or two later. And if you can move to the next slide, you see that the dot moved across the sky, and then to the next slide. And now we see that the same object kind of moved across the sky. We would like to connect those dots. So the next slide will tell us the trajectory of that newly discovered asteroid. The arrow points where the asteroid is residing now. And the first question that pops into my mind, at least, is that where is this asteroid headed? in the future? Is it going to impact with our planet and potentially cause damage? So some of my colleagues are experts on those orbits, and they study the orbit of this asteroid and similar asteroids, and can tell us whether in the future that asteroid is potentially could come back and impact with us. So again, maybe some of you would want to be experts on those orbits and calculate and tell us if we are safe or not. If we are not safe, we would like to defend, to do something about this asteroid, because we want to prevent this asteroid from colliding with our planet on some city and cause damage. Let's move on to the next slide. How do we do that? One of the ways to do that is to launch a very heavy spacecraft on a rocket and cause the spacecraft to collide with the asteroid and give it a nudge, give it a push, just move it away from the Earth. So in my education, I'm a rocket scientist. I work on those rockets that launch satellites into space for different purposes. But in that case, it would be to launch a spacecraft that would collide with the asteroid and move it off the Earth and maybe save the Earth from some big damage one day. So let's move on to the next slide. Here's an example how an asteroid comes to collide with our planet Earth, and if it wasn't stopped, it would create a huge damage somewhere on the surface of the Earth. And let's move to the next slide and see how we would propose to do that, right? We would launch a spacecraft that would collide with the asteroid before it collided with Earth and move it away from the Earth. And by doing so, we can save our planet from the damage by this asteroid. So the area is called planetary defense. We want to defend our planet from those asteroids. And I'm a member of the community of planetary defenders that study how to do that most effectively. Maybe some of you in your future will become planetary defenders by studying the mathematics and the physics that is associated with designing those rockets and designing those spacecraft and learning about those orbits and try to find out how big are those objects. So with that, let's move on to the next slide. And in conclusion, I would say be prepared, right? We have to be prepared. We have to find them before they find us and be prepared to defend ourselves. Because you are still students in school, I will give you a mission. And so the next slide will give you a mission for your school, which is do well in school. If you will do well in school, you do your math and physics and music and other things that are interesting, you can be a scientist or an aerospace engineer and do those kind of cool things. And with that, I'd like to thank you on the next slide and take some questions if there are any.
Awesome. So thank you for your presentation. So students, now as we turn it back over to you, let's see, round of applause. You can't hear it right now, but we see the applause. She pans the camera around. The crowd goes wild. So yeah, so Tracy, I see you unmuted as well. So we'd love some questions from the students and see what they'd like to ask about.
We are ready when you're ready.
We hear you. We're ready.
Okay. All right, John.
Hi, I'm Caitlin, and I was wondering, in the case that multiple asteroids are on a collision course with Earth and are supposed to strike at the same time, what would happen if NASA only had time to devise like one or two?
Can somebody repeat the question? I didn't quite catch it.
In the case that multiple asteroids were to strike Earth at the same time, what would happen if NASA only had time to deflect like one or two of them?
Oh, so I guess the question, if two asteroids were to come to impact with the Earth, and we can only deal with one of them. So that's a very interesting question. The first time that I heard those questions being asked, I would say that in general, those asteroids will not be equal. Maybe one of them will be small and the other one will be a large one. So we will deal with the one that could cause the most damage, right? We would like to deflect the one that could cause the most damage, or perhaps one of them will hit in the middle of the desert and the
Yeah,
other
in the
one will hit in the
population.
middle of a city and cause damage to property and to life. Obviously, we would want to eliminate the one that causes the most damage to life and property, right? So I would say this would be the right thing to do to minimize the risk to anything on our planet. A very good question.
Very good question.
And please hold the mic close to you so I can hear what you're saying. And you are muted, I think, right? You're on mute?
Yeah, no, I think they're unmuted, but we can't hear the question.
Yeah.
No, there you go. You're good now.
What is the furthest distance you can find an asteroid in space?
I didn't catch the question, I'm
Yeah.
sorry.
I think what is the furthest distance that you can find an asteroid?
I
Is
did
that what
answer.
you said?
Oh, the
How
furthest
far away
distance.
are they,
Yeah.
Nahum?
Oh, how far? Okay, so they typically find asteroids. So, okay, let me go back one step. He says it's easier to find the asteroids when they are close to the Earth. And their orbits take them close and far from the sun and from the Earth. And so it's easier to find them when their orbit brings them close to the Earth. That is one part of the answer. The other part is that the way we find those asteroids is by looking at the light that is reflected from the asteroid, the sunlight that is reflected from the asteroid. So we can only see the asteroid at a specific angle where the light of the sun is reflected towards the Earth. So the asteroid could be close to us, but we won't see it because we are on the wrong side of it. We are on the dark side of the asteroid. We just won't see it because the asteroid itself typically does not reflect any light from its dark side. The other problem is that the asteroid could be close to us, but it could approach us from the direction of the sun. So we are simply blinded. Basically, in the middle of the day, we cannot see those objects because we are blinded by the light of the sun. So the distance is less important than the angle from which those asteroids approach the Earth. However, we can find, and the other parameters that is important here is the size of the asteroid. A small asteroid will be much more difficult to find than a bigger one. And so the bigger asteroids mostly have been found by NASA telescopes. Today, they say that they found probably about 95% of the really, really big ones that can cause a lot of damage. And they're easy to spot from pretty much any distance. The smaller ones that can damage a city or a small town are much more difficult to find, and those will have to be found when they come close to the Earth, maybe around the distance of the moon or a few times the distance of the moon, you'll be able to spot them. One of the things that NASA is doing today to help out with this problem is they are designing a mission of a spacecraft to go between us and the sun. And that spacecraft will look at the illuminated side of those asteroids and will tell us, aha, be prepared in about a week or two, or maybe a year or two, an asteroid is going to approach the Earth, and maybe we can do something about it.
Francisco, I was wondering how would an asteroid hitting Earth affect the ecosystem?
Did you catch that one? Yeah. So how does an asteroid hitting the Earth affect the ecosystem?
Oh, the ecosystem. That is also a very good question. It depends, of course, where the asteroid might impact. If the asteroid is really, really large and it hits in an urban area, it will destroy the urban area, including everything that's around it. If the asteroid will hit in a place which is a body of water, either a big lake or in the ocean near the shoreline, there's going to be strong tidal waves that could disrupt the structure. near the impact area and cause tsunamis and things like that. It could disrupt the water supply to big cities. So we did a study a few years ago where we looked at an asteroid that might impact the water supply to Los Angeles that comes from North California and from Colorado. And we would say, what would we do? What would a city of 14 million people do if half of its water supply is suddenly disrupted? It's a huge disruption to the well-being of the city. And that's something that is true almost in every big city around the globe, which relies on supplies that come from the surrounding. So it's a very good question. It could impact the surrounding of the impact area. One of the things that had happened in the past is that large impacts by asteroids can cause fractures in the tectonic plates and change the course of rivers, change the underwater aquifers that contain water that we use for our well-being. That's something that can happen. Yeah, I think that's it.
My name is Arnett. What precautions can we take here on Earth if we are in imminent danger?
Again, can you repeat it, please?
Yeah. What precautions should we take on Earth if we feel that we're in danger of something coming in? So what else can we do? Yeah.
That's also an excellent question. It depends how much time you have to prepare. Ideally, we would like to find those asteroids well in advance, so we can design a rocket and a spacecraft that would be flown to collide with the asteroid and either deflect it away from the Earth or just destroy it. This is the ideal situation, but we are not always as lucky. In some cases, we find those asteroids just too late to design a rocket and launch into the asteroid. And so potentially we could explode a big bomb next to the asteroid and try to destroy it into small pieces before it collides with the Earth. And if it's just too late and we have not enough time to do anything about it, and some level of disaster might happen somewhere, then we would at least like to know about it maybe a week or two before the event and do an evacuation. Similarly to the situation with a hurricane, right? When we have a hurricane that would hit Florida, they never really know exactly where that hurricane, the eye of the hurricane, will hit shoreline. So they create large areas that people along these areas are alerted to watch for the landing of the eye of the hurricane. And maybe a couple of days before, they tell those people in this region where the eye of the hurricane is going to hit to evacuate their houses, save their lives. They might not be able to save some of their property, but they will be able to save their lives. It's a very similar situation with an impact of an asteroid. They might tell you that in a week, an asteroid might impact a certain area where people live, and will give them a week to evacuate their neighborhood or their little town and save their lives in case of an imminent disaster in this area. So that's the kind of thing that we are doing to protect our community.
My name's Maddie, and I was wondering what would happen if an asteroid was attempted to be redirected away from Earth, but instead broke off a piece and sent it towards Earth.
Yeah, please repeat.
Yeah, of course. So I believe the question was like, what if we did try to, shoot the asteroid or blow it up, but then those pieces are still coming towards Earth?
Yeah, very good question. So again, ideally, we would like to blow it up to either pieces that will miss the Earth completely, or to small enough pieces that will burn out in the atmosphere. So these are the two things that we would like to be able to do. But it's a good question because we have never done anything like that, and we would have to test it, right? We would have to maybe create a test in space that would try to blow up an harmless asteroid and just see if we can blow it up into smaller pieces or into pieces that will fly away from the epicenter of the trajectory. we would have to devise a test that will show us what really can be done. Today, the way it's done is in tools that are called simulations. So people are devising computer programs that put the physics into the computer program and simulate how such an event would occur, right? So they would run a certain asteroid size with a certain explosion that would occur next to the asteroid and see if in simulation we can blow up the asteroid into small pieces. But simulation is not like the real world. We would have to test it in the real world. You may have heard that about a year and a half ago, NASA completed a test. It was called DART. DART was a spacecraft that NASA launched toward an asteroid, and it collided with the asteroid to show that a spacecraft can nudge the orbit of an asteroid. It was very, very successful. That was a successful test of something that's called kinetic impact, where the spacecraft would collide with the asteroid. The question that you were asking is to blow it up with a bomb. So we would have to devise a test that will do exactly that to know whether we can actually do it or not. Go ahead. I think there was something in the chat for me.
Yeah, actually, really quick. Leanne, I know you've mentioned a couple things. Do you want to jump in and just, I guess, provide a couple of updates on some things that maybe you're mentioning, and then we'll get this next
Yeah,
question
I
in.
wanted to just drop in a couple things. These questions are fantastic. The CETA students are super coming up with really great questions. I wanted to mention that I put a link in about the NASA Psyche mission. And Nahum, I was wondering, maybe since these kids are in school right now, it launched last year in 2023, and it will find its destination, a spacecraft that's going to travel to a metal-rich asteroid, which has, if you could talk about the similarities of why we would care about that. And I put a link in about that. I also wanted to talk about how this isn't just something in America that we're looking at, but there's an international community of planetary defenders. And I mentioned the Planetary Defense Conference, but this is global. And then I did put in the link about DART, but great questions so far. I'm loving them.
Thank you. Yeah, I can briefly talk about Psyche. Psyche is a mission that NASA put out to an asteroid by the same name. It's an asteroid that is metal-rich. It is a large asteroid that is embedded inside the asteroid belt. It's not a threatening object to the Earth, and it's a purely science mission. They just want to learn about the science of this object. So it does not have anything to do with planetary defense. It's an object that will never come to collide with us, but it's a really, really cool science mission. So maybe some of you might become scientists that would like to know a little bit more about what these asteroids are made out of.
And I think it's so neat because we're also a metal-rich planet. The core of Earth is also a metal-rich planet. So we have something in common that's out there in the asteroid belt. And I know you showed that slide where you started on the left with the sun, and you showed where that asteroid belt is. That's where that Psyche mission is. So to think about it, when you're planning out, like, how long is it going to take you to get home? NASA planned that mission out using some of the types of careers that you mentioned earlier in your presentation. The spacecraft left in 2023, and it's going to get to that asteroid belt in 2029. So, some of these kids are still going to be in high school when that happens, or maybe just having graduated. So just thought I'd bring that up.
But today is the time to decide to be a rocket scientist. And so, yeah, that's a very cool comment there. That's right. One more thing about the Planetary Defense Conference. So I am one of the organizers of international conferences that are called Planetary Defense Conferences, where world experts converge in a place around the world. Obviously, the problem from asteroid is not a political one. It is a hazard that is made by nature. And so we would like to team up and collaborate on defending our communities worldwide.
I think we have another question.
Yes, go ahead.
Yes, yeah.
Hello, I'm Nicholson, and my question is, could a satellite with a rock-cutting laser on it would be able to destroy an asteroid that could cause damage to Earth?
I think I had trouble hearing that one. Can you try to
Okay, so
one more
there's
time?
Is it about lasers and
laser on it, be able to destroy an asteroid.
Oh, laser, to use laser to
Lasers.
destroy, that was the question?
yeah, I think so.
So again, I'm not an expert in this particular field, but from what I know, there were some scientists that were looking into shining very strong laser light to those asteroids and affect their orbit. I believe that the physics is there, it's possible, but the amount of electrical power that would have to be devised to power up those lasers is probably out of our reach today. Maybe in the future, we would be able to build those large power supplies that would power up those lasers out in space and try to deflect those asteroids by shining strong laser light into them. So yeah, that's a good question. Sometimes some scientists are actually studying exactly that field.
Yeah, I just looked on
Yeah.
Google, but it like 3000 Kelvin seems pretty hot. I don't know if we can get that high here.
Exactly. Yeah, go ahead. Somebody was about to ask a question. Go ahead. And I think you need to go
Yeah.
out on mute.
Yeah, we can hear it.
Or put the microphone right up to your mouth.
I think he's mute. You need to unmute the screen.
It's I think the microphone is off.
Oh, it's on the microphone. Okay. Okay. Yeah.
Can you say
Somebody
that
might-
again, Tracy?
Okay, so will the DART aircraft be produced in large numbers if it's successful, like 50 to 100, or will there only be a few?
Can you repeat it, please?
One more time, Tracy. One more time.
Okay, will the DART aircraft be produced in large numbers, like 50 to 100, if they're successful, or will it only be a few?
Yeah. Did you catch that one? So the DART aircraft, will it be produced in large numbers, like 50 to 100, or is it only like a few of them?
The DART?
Yeah, I believe so.
No, the DART was just a one-time experiment.
Mhm.
It was a one-time experiment.
Proof of
No, I
concept.
don't think.
Isn't it called like a proof of concept? They were looking to see if they could do that.
Correct.
And I think
Correct.
the result was they did it phenomenally well. So I think that was the outcome of that.
Exactly. So this was a very successful test. And the next step would be to try to do other things, maybe deflect an asteroid using several other techniques that are being proposed. So I'm not aware that NASA or anybody else is doing any of that. But I think it's an important thing to do, to go and test those different concepts to know which one of them would work best. Earlier was mentioned that an explosion of some device next to the asteroid might do it. I think it needs to be tested in space to know whether that technique will actually work or not. But it's not going to be a large number of those. Hopefully, after a few tests, we can just build a system that will do it for us, right? Just like we have preparedness for different type of hazards on the Earth, we might have a planetary defense system that would be ready to launch to an asteroid and mitigate the danger from this object.
Looks like we have another student, but I do want to make sure, Nahum, that you talk about before you go the Artemis project briefly too, because I know you're involved with that as well.
Of course. So the Artemis project is unrelated, obviously, to asteroids and to the space hazards. It's part of NASA's endeavor to put communities, to put astronauts on the moon again, and to create outposts on the moon. And in fact, they have much bigger vision, which is going from the moon to Mars in the future. So the moon is more of a stepping stone for that bigger vision. I'm on the project that designs part of the Artemis rocket. The Artemis rocket is made out of a very large booster phase, an upper stage, and then the Orion, which is the crew module. It's where the astronauts are residing inside and flying. I'm in charge of the upper stage. So I'm leading a team here, which makes sure that the upper stage flight is going to be as designed and as expected. So it's cool to be a rocket scientist working on a rocket that is going to launch to the moon. So maybe some of you will be rocket scientists that will launch rockets to Mars and beyond. Yeah, go ahead for the question. And I think again, the mic needs to be turned on.
Still not hearing the mic, yeah.
Hello, my name is Benjamin. I was wondering what the asteroid and a meteor is.
Did you say what the difference between an asteroid and a meteor? Is that what you said?
Oh, an asteroid and a meteor. Okay, yeah, this is an excellent question. And it brings up a little bit of a misconception. Sometimes you hear in the news that a meteor hit somebody's house or some property. But meteor is not an object. A meteor is just the light phenomena that occurs when the object passes through the atmosphere, hits up, and emanates light. So the light that comes out of an object that passes through the atmosphere is called a meteor. The object itself could be an asteroid. A meteorite is the actual object that makes it down to the ground. So it's part of that asteroid or comet that survived the atmospheric entry and made it down to the ground. When it enters, it emits light, which is called a meteor. And there is an interesting anecdote associated with this, that it was the ancient Greeks that came up with the name meteor, because 2,000 years ago, when they were seeing those objects burn out in the sky, they had no clue about asteroids and about comets, and they thought it's just another meteorological phenomena. So they called it a meteor. They knew nothing about those space objects. And today that name kind of stuck as an object. So many times in the news, you hear about meteor hit a house or hit a region, but the meteor is not an object. It's just a light phenomena.
Very cool.
My name is. Yes, that's perfect. My name is Nahum Melamed, and I was wondering if an asteroid landed in the ocean, how would it affect all the marine life?
I would have to have the question repeated.
No, of course, of course. So yeah, if an asteroid lands in the ocean, then how does that affect marine life?
Okay, good. Again, it depends on the size of the asteroid. A small one probably will not cause much of an impact on the marine life. And I'm saying a small one, I would imagine that an object the size of 3 or 4 school buses, maybe 50 or 100 meters, will cause obviously a local damage, but not something that would disrupt the entire environment. If a bigger object that is several hundred meters in size would impact in the ocean, I'm sure that it will cause a large disruption to the marine life in the region. But I don't know enough about that type of biological processes. I'm just guessing that it would cause some damage, especially the big ones. Yeah.
Awesome. And so we're actually going to just take one more question. So if I see we got our student already, you're our closer. So let's have our last question from the student here.
Perfect.
Mm-hmm. No,
and again, turn on the mic.
Can't hear you.
Orbit into a planet or like around it, so basically turning it. Is that possible?
So say that again. So we hear you at the end, but didn't hear you at the beginning. So come close, and then we'll catch your question again if you want to ask.
Put your mic into the
No.
closer.
Is there any way to redirect an asteroid into a planet's orbit? So in other words, turn an asteroid into a moon.
Ooh. So I'm pretty sure what they're asking is there a way that you would take like an asteroid, like let's say it's big enough, into another planet's orbit, and then it would end up kind of just like naturally staying a part of that orbit, so it ends up kind of becoming like a moon for
It's
that
like
planet.
deflecting it to another
In
orbit.
orbit, yeah.
Mhm. I haven't heard about this particular solution. I think potentially it could be done, but it would take much, much bigger effort than just deflecting the asteroid away from the Earth. Our minimum requirement is to simply save the Earth, right? And if we deflect the asteroid away from the Earth, typically the asteroid will not come back to hit us in decades or even hundreds of years. So we could leave this to the future generations to deal with. To move the asteroid to another orbit around another planet, even though potentially it could be done, I don't see any practical benefit of doing that beyond just saving the Earth, because you already have done it by moving it away from the Earth.
And it's expensive to launch a rocket with a spacecraft to then deflect it into a certain location and just the additional cost. Is that right, Nahum?
Yes, we would like to do that with a minimum amount of effort, right? So any additional effort that we would expend is going to consider a waste. So we don't want to do anything beyond just the minimum effort to save the Earth from an asteroid.
Awesome. And so
Well, I
thank you.
think that might be somebody who
Yeah.
could study that
No, absolutely.
as a
Absolutely.
career.
Ways to more effectively do that for sure. And with
Yes,
that,
I just want to say last words that I wish that at least some of you will become experts in the science, technology, engineering, and math that is involved with this kind of cool activities. Maybe some of you will become astronauts, maybe some of you will become pilots, and some of you will become experts in what the asteroids are made out of, the materials that those asteroids are made out of. Some of you might become experts in building the rocket that would launch a rocket to the asteroid and to other destinations. Maybe some of you will walk on the moon one day, which is going to be a cool thing, I think. So I wish for you to do very well in school, just excel in school, and your future will be much better.
awesome. And then I'll pass it over to Wayne to issue out some closing statements and remarks for us.
Thank you, Carlos. And on behalf of all of those on the screen, that is Leanne with Aerospace Corporation, Dr. Melamed with Aerospace Corporation, Carlos with UTSA, Jill with UTSA. And we all want to join in thanking CETA Magnet School and all of the students that have participated by attending this presentation, and all of the great questions that have been asked. And without everyone on the screen, including the school, most importantly the school, this wouldn't be possible. And so a special shout out to all of you, and thank you all for your participation. And I think we should all, including the students, give a special thank you to our special guest presenter, Dr. Nahum Melamed from the Aerospace Corporation, for a fantastic presentation, which is being recorded and which will be on our website shortly. So thank you all. Big round of applause.
Thank you very much for listening, and do well in school. Remember to do well in school. Good luck with everything, and thanks for inviting me.
Oh, it's our honor. Leanne, do you have anything else on behalf of Aerospace Corp?
No, just I agree with you, Wayne. This has been so great. Great questions. What a fantastic audience. I think we have some future planetary defenders out there. So thank you so much for having us.
Well, my big question, which doesn't require an answer, but from my generation, which goes back almost longer than those asteroids that you put up on the screen, I was constantly thinking about when I grew up and somebody would ask a question or somebody would do something not so smart or whatever, there was a phrase that was used, and the phrase was, "It's not rocket science." And so as I was thinking about all of this, I was thinking about, well, it is rocket science, in fact. Jill, do you have any closing remarks on behalf of UTSA Police College?
Just a big thank you again to Tracy and the school and to the Aerospace Corporation as well too. And just has been a fun experience. And I feel like I've learned a lot. I definitely didn't know about Meteor. So that was a definitely one to a takeaway for me. But thank you all. Appreciate it.
So
Thank
with
you.
that, we thank you all and we'll sign off and stay tuned for the recording on our website. Thank you.
Thank you so much. Have a great day.
Thanks.
Bye, everybody.